Well, I saw this question on YouTube. Now I have my way of doing it. I have two methods, and I think my methods are great because I haven't seen anybody else did it. So the first method is using the unit circle. Well, I know that the 12th 12th unit of a unit is equal to cosine uh, 2 2n pi, which means 0. Now, this is 0. Cosine 0 is equal to 1, right? Plus I sine 2n pi to the 12th. That is the 12th root of a unit. And n equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, and a 6. Okay, so namely these are 12 roots. This one and that. This one is this, n equals 0, and this is n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5, and n equal to 6. So 12 roots. These are 12 roots of a 12th root of 1. Yeah. So this one is equal to cosine n pi over 6, right? Plus I sine n pi over 6. Yeah. Okay, if I assume that theta is equal to n pi over 6, then my 12th unit of 1 is equal to cosine theta plus I sine theta. Just simplify to use it in a calculation of x. Okay, so this is my 12th root of 1. Okay. Now this equation is actually x minus 1 over x is equal to 12th root over 1. Okay, so this means that 1 minus 1 over x is equal to cosine theta plus I sine theta. So from which we know that 1 over x is equal to 1 minus cosine theta minus I sine theta. Okay, so x is equal to, we are looking for x, aren't we? So this one is equal to 1 over 1 minus cosine theta minus I sine theta. Okay, so how to find x? Of course, we are multiply the conjugate of the denominator, same time multiply the numerator. So x is equal to, the conjugate of this one is 1 minus cosine theta and plus I sine theta. And multiply this conjugate is equal to 1 minus cosine square right, plus I sine square x square theta. And this one is equal to 1 minus cosine theta plus I sine theta. This will be 1 minus, well, 1 minus 2 cosine plus cosine square plus sine square. So it's end up with a 2, 1 minus cosine theta. Yeah. So we simplify into 1/2. This over that is 1/2 plus half I and sine, yeah, 1 minus cosine. Well, this is the cotangent half theta. So this will equal to 1/2 plus I over 2 times cotangent half theta. So we find x. Okay, we are looking for x, right? I find x. X is equal to 1/2 plus I over 2 cotangent half theta. Theta is this. Theta is n pi over 6. So this is a cotangent and n pi over 12. So I found the x. This is my x. And n equal to those things, right? 1, 2, 3, 4, 5, and a 6. But unfortunately, cotangent 0 is not defined. So we delete that one. So we have 11 roots. These are 11 roots for x, So if we want to more specifically, n equal to 1 plus or minus 1, huh? Because 0 is not defined. Then x1 and x2 is equal to 1/2 plus or minus plus or minus half I cotangent 12 pi over 12. Yeah, since this is not nice number, so I just leave it. And n equal to plus or minus 2, then x3, x4 is equal to 1/2 is root plus or minus root 3 over 2I. Okay, so we find 2. And n equal to plus or minus 3, x5, x6 is equal to 1/2 plus or minus n equal to this, n equal to 3, this is a quarter pi. Quarter pi, cotangent 4 pi equal to 1. So, yeah, n equal to plus or minus 4, this is f7, 6, 7 and 8 is equal to half and plus I over root 2 root 3 minus, okay. And n equal to plus or minus 5, then x9, x10 is equal to 1/2 plus or minus cotangent 5 pi over 12. See? Finally, n equal to 6. N equal to 6, then x, the last one, x11, it's half pi, right? Half pi equal to 0, so they equal to 1/2. Yeah, we have 11 roots. You see, I think this method is great. I'm using unit circle. No? It's a great method because nobody did it. Well, at least I haven't seen it. Okay, this is method 1. Method 2. It's a great method. I haven't seen anybody use it. So I'm glad to present here. And I let the x be r cosine theta plus r I sine theta. Namely, r is a modulus, theta is an argument for x. And then then 1 over x is what? 1 over x is equal to 1 over r cosine theta minus I 1 over theta sine theta, right? That is 1 over x. And we have a we have an equation that's saying 1 minus 1 over x is equal to 12th root over 1. So from this equation. So therefore, 1 minus this, right? Therefore, 1 minus 1 over alpha, 1 over r cosine theta this is minus become plus, right? Plus I r sine theta is equal to 12th root over 1. 1 minus this. Yeah. Okay, this is a complex number. The modulus is 1. Okay. So this complex number, the modulus must be 1. So what is this modulus of this complex number? That is 1 minus 1 minus r cosine square plus, this is square, right? Plus 1 over r sine square must be equal to 1. Because the modulus of this complex number is 1, so is this complex number, the modulus, which is this, equal to 1. And this one is equal to, then this one is equal to 1 minus 2, right? Cosine plus 1 over r square cosine square plus 1 over r square sine square is equal to 1. And 1 cancel out, right? This one plus this one is equal to, this one plus this one is equal to 1 over r square. Let's go to 0. 1 cancel out. This plus this one is this. So this is this. So we can find cosine theta is equal to 1 over 2r. So we put a cosine theta over there, here rather. So x is equal to r, right, times cosine theta. which is 1 over 2r plus uh, plus r, r I sine theta. So which means equal to this equal to half. See, it's good. We find the real part of x is a half plus I. Right this way is better. Yeah. Now, something interesting. This is my x. My x is the real part is a half. This is half. X must be there. X is there. See, just a matter of argument. See, this is this is x. X is a complex number. It's a real part is half. This is theta, right? Therefore, this is what? This is r times sine theta. This is r times sine theta. That's exactly my imaginary part, r times sine theta. But since this is constant, this could be written as a half tangent theta, right? This is a constant, half. This is theta. This is half tangent theta. Therefore, my x is equal to 1/2 plus 1/2 tangent theta. Wow. I found x. I did find x. She just a matter of theta. If we find theta, we find x. See, this is a great method. Yes, I think the method is great. I haven't seen anybody did it. And now, how to find the theta? We go back to this equation. Okay, now let me try to explain it. Okay, x is a complex number. This is a real part. This is imaginary part, right? Therefore, let me write this way. The modulus of x is equal to, now the real part rather, sorry. The real part of x is 1/2. And the argument of x is theta. Yeah. And what is x minus 1? X minus 1 will be equal to -1/2, right? X minus this. Minus, yeah, minus, not minus, this one -1, okay, this -1, so there's still positive, half x tangent theta. Now let me draw a picture here. This is half theta. half. This is half. Sorry, not half theta. This is 1/2. X minus 1. X minus 1 must be on this line. They share with the same imaginary part. Imaginary part is the same. This one and the x, the imaginary part is the same. Now the argument of x minus 1 is this angle. What is this angle? This angle is pi minus theta, right? So it's a pi minus theta. Yeah. The real part of x minus 1 is negative half. I tried to catch the main feature of these two complex numbers, which is x minus 1 and x. Now we are looking for theta, right? If we find theta, we find x. Now, let me see. How do we find the argument, which is the theta? So we find x, right? Now, this equation says that 12 times this argument is equal to 12 times that argument. 12 times this argument is equal to 12 times this argument. This is what? This is the de Moivre theorem, right? So we have argument, right? So 12 times this argument. 12 times this argument is equal to 12 times this argument. This argument is theta. But don't forget that the angle could be, multiple of 2n pi. So that is a relation. That is a relation from which we find it theta. Okay. Now then we simplify this one. Simplify this one, and theta is equal to pi over 12. 6 minus n, right? And whichever n satisfy for the validity over theta. Now, what is theta? Theta cannot be more than half pi, because theta must be, here or there, right? So could be less than. That is my theta. So we choose those n. Come up the theta is there. No, that will be our theta. That will be our n. And so we find. So we are looking for x, which we are looking for theta. Theta is coming from here. This theta is coming from n, and as long as satisfy, this. Well, I think it. Okay. Let's see. N equal to 0. N equal to 0 is a half pi. Half pi is not allowed. It's not good. N equal to 1. Then theta is equal to 5 pi over 12. That's good. That's good, you see. N equal to 2, n equal to, that will be third pi. Right? Third pi is okay. N equal to 3, n equal to 3, that will be a quarter pi. That's good. N equal to 4, n equal to 4 will be 6 pi. It's good. N equal to 5, theta will be 12 pi. That's good. Now let me use space here. N equal to 6. N equal to 6. Theta is 0, right? Well, no, 0 is good. It's valid. N equal to 7. N equal to 7 is negative pi over 12. That is good. This is good. N equal to 8. Theta is equal to negative pi over 6. That is good. N equal to 9. Theta is a quarter pi. That's good. N equal to 10 and negative third pi. That's good. N equal to 11. That is equal to negative 5 pi over 12 on this one here. Okay, n equal 12. That will be equal to negative half pi. N equal 12. So negative half pi, which is not good. So that's it. We have 11 roots. Okay, so finally we have x is equal to 1/2 plus half I tangent theta, and theta is those angles, right? Plus or minus 5 pi over 12, plus or pi over 3, plus or minus pi over 4, plus or minus pi over 6, plus or minus pi over 12, and finally whichever pi is 0, see? 2, 4, 6, 7, 2, 4, 6, 8, 10, 11 roots. Yeah. If you put these angles into this theta, we find the 11 roots. Same thing as we did in the first method. It's a great method. See, so you have 11 roots, which is the same thing as we have just done it here. Yeah, we have 11 roots. So I'm happy to present these two methods. I think that these two methods are great because nobody did it. Thank you for your